Good afternoon everyone. Today we have the first part of the test media players in HDR mode. We will check on the test patterns. So today's comparison is more theoretical than practical. Because in real life you will not watch such complex elements. But today's test will give us the groundwork to see what the media players are theoretically capable of. Unfortunately in the test will not take part Fire TV Stick 4K because HDCP have not yet managed to bypass HDCP on streaming boxes like TiVo and Fire TV, enabled even for the interface. So although the offense, but we will be without it. As usual, I captured the stream directly through the HDMI output of the media player to the HDMI input of the capture card. I captured it in 4K with frequency 23.976, color space BT 2020. For example, media info of the resulting capture file. See the uncompressed V210 codec. The capture card saw HDR10 4200 Mbps stream with 4K resolution. Frequency 23.976, color space YOV. The card captured in 422 10-bit and accordingly. Here are the characteristics of the file itself, which I captured for the Apple TV example. Apple TV sent to the capture card, as well as on a regular TV characteristics of the video. Note here PQ 3999, although the file itself has a PQ equals 1000, this is a clever trick of Apple TV. Though perhaps it's a trick in Fuse. It outputs all the video files remaking them in PQ 3999. But here's a strange number, and if you turn on the interface Apple TV HDR mode, it does not specify PQ value, indicated 0 for all parameters. This is because, for example, in YouTube app Apple TV outputs with PQ 1000, for example. If we watch a video in YouTube app, it will be PQ 1000. Return to the interface from YouTube. The interface will remain in PQ 1000 mode, but if we go to Infuse player after that, it will switch to starts any movie to PQ 3999. Then exit Infuse, it will keep PQ 3999 until you go back to YouTube and get PQ 1000. I will demonstrate what video files I tested. We had a clip of grayscale. HDR test for clipping and correct output on the brightest elements. The same file on the PQ 4000 and the test table on which you can immediately assess both gradients and color gradients. And high-frequency elements. Also the correctness of the conversion of 420 to 422, as well as diagonal lines, used to determine how correct and quality color interpolation is done. HDR table test video file was with the PQ 1000 and with the PQ 4000. And there was also a video with a color test. This output a different brightness for each color. In this test to check how true and correct output a different brightness. Whether there is clipping bright elements with peak brightness. I will not describe each test in detail because it would be too long a video. I will talk about the basic most interesting tests. By the way, many TVs ignore the PQ parameter and create their own dynamic PQ for each frame of video. So does TV Sony and LG. Probably for this reason the difference with Dolby Vision is not very visible on these TVs. The first test is the output gradient. I did testing in the program DaVinci Resolve. I will show its interface, but then removed because you cannot see the graphs. Look, I have already cut pieces from each video and put them on the timeline. All tests I did in the same order. 1 original. And then alphabetically. 2 Apple TV. 3 Dune Real Vision. 4 Shield TV Pro. 5 X2 Cube in ATV mode. 6 X2 Cube in Corelect mode. Further analyzed with the help of graphs each picture and compared it with the original. As we know, the grayscale should be output perfectly. Because interpolation is not applied to them and each brightness pixel is coded. The colors are restored from 420 as in normal Full HD video. If we have color resolution of 960 by 540 on Full HD. On UHD we have color resolution of 1920 by 1080, that is why the color sharpness seen on UHD video is a priori better than on Full HD. And of course 10 bits makes itself felt. 876 theoretical shades of each color against 224 shades for Full HD video. I have not made numerical measurements here, we will evaluate by the difference in graphics from the original. The greater the difference in the graphs shown by DaVinci Resolve, the more this TV box is different from the original. I think everyone agrees with this methodology. Because it is difficult to apply some kind of quantitative assessment. Let me immediately explain why Dune has as many as 3 options for graphics. The fact is that HDR video on Dune can be obtained in 3 ways. The first is if Dune has full output mode in Android and setting the bitrate output of the original file as is. That is, with the bitrate of the original file in the settings. As I was prompted in Telegram chat, it is in this mode we get just the right levels of blacker black and whiter white. I checked, indeed all goes well in normal Full HD video, as other media players. This is the mode where we can get HDR without clipping. The second way to get HDR is to set the VS10 engine to HDR enable mode. The third way is when we leave VS10 and all the parameters in auto mode. Interestingly, all 3 of these options output a different picture. First I will show the problem with Dune. Then I will remove this window so that it does not interfere with us, otherwise I will not be able to control the interface. What's the problem with Dune? It can't output gradations properly, no gray shades, no colors. Here I will show the defects on the gray gradient. Next you will see just how it shows up in the graphs. The gradient in any output of the 3 is stepped. But in different cases, more stepped or less stepped. Dune owners write in the comments, maybe there is some other option to get HDR. But in general the situation is sad. I have a feeling that Realtek is not able to output 10-bit at all and does it from the regular HDSDR mode 16 to 235 just stretching the values, at least, I see so from the graphs and the picture itself. Look now I will increase to 300. This is the output with a range of full, see the dropper in 10-bit mode, that is, it now displays the correct shades as they are. Look. The value of 440, I will move the dropper. 441. Sharply 443. Then 445. I move long. But the hue does not change. 446. 448, so there is no value 447. Then 450. And 449 is lost. And so on the whole picture, and in any of these output options HDR will be loss. That is, gradation is not smooth in any of the options. Let's switch it for now. The rest we will look at the graphs. So it will be more convenient. Look. We have graphics of the original. And because we have the original is already compressed. That is, it is not a high bitrate video stream. So here we also have a small step. That is, the gradients are missing a little. But about the same video you will have when you watch a normal movie. Let's see how Apple TV outputs. It outputs quite decently. You can see these lines at the top. You can see how smooth the gradient is. Look. This is the original. This is the Apple TV, overall it's fine. And this is the Dune. You see the gaps appear. Here's the Dune again. The graph is also not really smooth. Just here everything has shifted to the right side. This is the third output mode VS10 equals auto. Which means that in all modes the gradients are not rendered very well. Next. Shield TV, it outputs a little worse than the Apple TV. Here is the Shield TV. And here is the original. That is, the Shield TV has some gradients disappeared a little. But not critical, the picture looks quite smooth. Next is the X2 Cube. This is X2 Cube in Android TV mode. And here is the X2 Cube in Corelec mode. There are no differences. And for example the difference with the original. I'll say this from the graphs. Both Apple TV and X2 Cube put out identical grayscale. That is, we can say that they put them out perfectly. Shield TV in second place. Dune in last place. Next test. I immediately output so that it was more convenient to look in the program paint.net. Collected all the graphs in one place so that it was easier to compare them. This is, respectively, the Hdrp Q1000 test. The picture looks like this. Basically, it's not very informative for us, it's more for checking the TV test, but I decided to play it anyway. Mode with color range equals full. But in general it doesn't affect here because it's almost identical. Now, we see this is the original. This is an Apple TV. It's quite good, there's nothing wrong with it. Next is the Dune chart. You see it's how bad it is. At this brightness the hue jumps. Look at the histogram, this is the distribution of pixels by brightness, i.e. the more pixels, the higher the peak. In this mode the Dune, as well as in the gradation mode, did not display the image very well. The second Dune mode. The same picture, nothing changes. Next, Shield TV. It's generally good. The only thing here is one peak down. That is, at the brightness somewhere around 680 it had a decline. Next is the X2 Cube. And here is the original. Again the X2 Cube. And this is a comparison with Apple TV. Again identical, that is, you can say that the grayscale that Apple TV and X2 Cube output the same. Shield TV lags a little behind. The next test. Here we display this table. From it you can understand as much information as possible about the quality of the output. You can quickly determine all image parameters and deviations. Here is the original. Look at this and this. If you imagine, it is the same picture. That is the original picture. If you present this picture here, I'm going to shrink it down. This is the gradation. Right here. 0 is black. And the higher up in the graph, the greater the brightness. Next is a gradient of color. Here it is. Next comes the table itself. Here unfortunately it is hard to understand. But the meaning of the following. The brighter the pixels, the higher they will be. These are the elements. This is this and this. And then the right side goes on. This gradient here. This gradient here. So you see. It is a pixel by pixel mapping of the brightness of the whole picture. So we can understand where the element is. And this part is divided into RGB components, the same picture. From this part we can very easily understand whether there is imbalance and whether the gradients are displayed correctly. Let's see. This is the original. Here is a vectroscope, which is very good for understanding if the colors are distorted or shades are shifted. And this is an ordinary histogram, as I said. So let's go. Apple TV. As you can see the test it failed. That's the problem. Now, I'll show it in a screenshot. It shows everything. See. It looks like everything is decent. But here it failed the test. There shouldn't be this white spot. There should be a smooth gradient. It failed it. And the gradient both gray and color came out correctly. Look at this part. You see these are just a high frequency elements. It didn't bring them out the way they should be. In the original they look like this. Look here. And this is how Apple TV put it out. It mixed it up and put the wrong colors. This is the original. And this is Apple TV. Again the original. And look here. Notice the slightly stepped diagonal lines. They're not as smooth as they should be. indicating that the interpolation was done by some simple algorithm. And here on the vectroscope, you see that Apple TV took away the colors, gave out other shades precisely because of color clipping. Or rather distortion of colors on the fragment of colors space conversion. You see how he brought out the colors. And here is how it was in the original. Next, Dune. In this VS10 equals auto mode it is quite decent. But pay attention to the gradients. Look here. And look here. And be sure to look at these color values. See here sharp transitions. That is, gradients are not smooth. And here is the original. Look here, smooth. And here not smooth. It feels like Dune is just taking 224 levels and stretching it to 876. The second option is VS10 equals HDR enable. It's bad here. Look what Dune does. It rotates the color triangle, colors, shades are distorted. Goes sideways, and in this mode, by the way. I'll show you. It's directly visible to the naked eye. How much the red color is affected. See the gradient. Here a small gradient. Not very sharp. Here suffered, here the gradient became a strip. Simply put, a nightmare, and respectively on interpolation. It has the same problem as the Apple TV. A little jagged lines. Well, in the third version of Dune. Here it is. If you choose between VS10 equals auto and the first version with full range HDMI. In my opinion, VS10 equals auto has better gradients. But in VS10 auto mode, it clips colors in the brightest shades. To be honest, I do not know. You can choose in what mode it is more pleasant to watch or lose and. Next is the Shield TV. It's pretty good overall. Except that it, just like Apple TV and Dune, failed to cope with the output of high-frequency elements. It replaced the colors and output them not as they are. Here's the original on the screen, look. And this is Shield TV. Again the original. Then strangely enough the leader again. I myself was surprised at how accurately you can look carefully. This is X2 Cube in ATV mode. And you see almost nothing changes. And look, between the ATV and Corelec, almost no difference. Only at the very bottom of the brightness range, I see some small differences. This is an interesting situation. And the last test I will show is the Chroma Test. Here we check how clipped colors and how accurately they are displayed and whether or not. Here too, for convenience, brought directly to Paint.net graphics. So it was easier to watch. So look. This is the original. This is Apple TV. Apple TV problem is that it seems to have shifted at the bottom of the range of brightness, which is very bad. That is, we lose and wrong output the most informative part of the image. It is not very good. The Apple TV lies at low brightness. And the image is mostly at the bottom of the range. And plus you also see it warped at the top. Which means it messes up the color balance on the bright hues. Next, a Dune in VS10 mode equals auto. Not bad overall. Here the Dune performed well. I put it higher than even Apple TV. Then VS10 mode equals HDR enable. Again in the trash, you see it distorts and shifts colors and completely wrong colors output. Not with the brightness that should be in the original. Next, the third option, HDR Full Range. Look. Let's compare VS10 auto and if the output with full range. Here they are approximately identical. But it seems to me that it makes more sense to clip. But at least the gradations will be smoother. Next, Shield TV. On the whole, performed well. I did not see any strong errors. A little only shifted the color saturation in the bright areas. In general, not critical. And again, the leader of our test is X2 Cube, look. But it's not a mistake, it's almost not distorted the picture. That is, it's closest to the original. There is a little error in the output. But it's not critical, you won't even notice it with your eyes. To summarize, as you can see, in first place is X2 Cube. Second place is Shield TV. Third place is Apple TV. And at the back of the Dune. Of course, it is a pity that I could not test MediaTek. I am very interested to see it because I think that it should cope better than Shield TV. Because it is the media chip, in contrast to Shield TV, which is more suitable for games and for gaming consoles. I have what we have. Maybe I'll invent something to test MediaTek. Or we'll buy an expensive device that bypasses HDCP. And I think Dune owners should bombard the Dune support because this TV box is not a quality picture and cannot be considered a high-quality image device. Especially for the price for which Dune is trying to sell the full version of their product. That's all. Thank you all. The second part will most likely be on the real test pictures. Plus, let's see how much difference there will be in picture clarity. That is, in the correct output of small elements. Image sharpness. But so far it is clear that, from all these media players, Yugu's X2 Cube is the best prepared to output in HDR format. To be more precise, not even X2 Cube. I think any Amlogic-based TV box, Yugu's X4 or X3, should output the picture identically to X2 Cube. At this point, sign up. Write comments. Thank you all. Goodbye.